Good evening. Welcome to Allgonine lesson 2. I want to discuss a few things with you today. I want to speak about the 369 Tesla code. And I'm going to start to show you how to zoom in on a number. So when we look to the figure here left on the paper, we see a hexagon is divided in 6, and we have now 6 triangular shapes. So when you look at the paper, you see a lot of triangles, not only these 6 bigger ones, you see also smaller triangles. So inside this triangle we can locate 9 smaller ones, and in each of the 9 smaller ones we find another 9 triangles. So 81 small triangles inside this shape. The first thing we do with visualization is the following. We just pretend the small ones are not there. So I'm gonna put a dot inside each triangle. Now I'm gonna replace the dots for number. As I showed in previous videos, we start with the 1, then we have the 2, followed by the 4, then the 5, the 7, and the 8 to make it complete. So this is how the numbers are positioned. So when we zoom in on the number 1, we go to the next figure. You see this is the 1. So when this is the 1, then we find the 2 inside here, we find the 4 inside here, the 5, the 7 and the 8. So we zoom in on the 1, and we are going to do the following. We know that the 5 is in here, so I will put the 5 here and another 1 there. So we know that the 2 is here, so then the 2 will be there. Here was the 2 and there was the 4. 4, 2, 4, 2. So what else do we know? We know that the 7 is here. 1, 2, 4, 5, 7. 5, 7. 7, 5. 5, 7. And then the 8 was in the opposite direction of the 4. And we put it here as well. So 4, 8, 4. 7, 2, 7. Well, it's not that I made it up. I will explain it to you. So we see 6 numbers here in the middle, and it was the same hexagon as we draw in the middle of our hexagon. 1, 2, 4, 5, 7, 8. But we still focus on the number 1. So 1 plus 2 is 3, plus 4 is 7, plus 5 is 12. 12 plus 7 is 19, 19 plus 8 is 27. So we see the 6 numbers we use have a value of 27. 1, 4 plus 7 has a value of 12. So this together is 39. And when this would be the middle of a system, we see the direction. 1, 5, 1, and to this side 5, 1, 5. So when we do for the 4 and the 7 the same, we just fill it out. This is the 8 and this is the 4, and the rest is easy. 1, 2, 4, 5, 7, 8. So the 4 has the 4 in the middle, and the 7 will be there, and the 1 will be there. So for the 4 is the same. 27 plus 12 is 39. The only difference is the direction, the positioning of the numbers. You see 4, 1, 7, 4, 7, 1. 1, 4, 7, 1, 7, 4. It's all different. So we could just look to these numbers: 7, 1, 4, 7, 1, 4. You can play in a lot of directions. You see the same here: 1, 4, 7, 7, 4, 1, 7, 4, 1. So when we come to the 2, the 5 and the 8, I will first finish the 7. So we can do this as well: 2, 8, 5, 2, 8, 5 we don't need here. And then it would be here the same: 4, 7, it has to be 1, 4, 7. And 2, 5, 8, 2, 5, 8. So again, 27 plus 12, 39. 1, 2, 1. 1, 2, 4, 5, 7, 8 is 27. 2, 5, 8. 2, 8, 5. It's all direction. So we see the 27 plus 15. 5 plus 2 is 7. 7 plus 8 is 15. 15 plus 27 is 42. So Mr. Nikola Tesla, he spoke about the 369 code. 39 is the same as 12. 1 and 2 from the 12 is 3. The 42 from the 2, 5 and the 8. 27 and 15, 42. 4 and 2 is 6. 39 and 42 is 81. 8 and 1 is 9. Three, 6, 9. So this is how we position the numbers. So now you know that each time when you see the 1, even if the 1 would be inside here, we just visualize 9 little ones and we fill out our numbers. And of course when you zoom out on this shape, this will be a 1 and that will be the 5. So when we go to the star, then of course our star is not flat. The star is like 3 boxes. One box in the top. Two boxes downstairs. So what I also liked about the situation from the numbers is the following. So these are 3 cubes standing in front of us. And when you look to Egypt, sometimes the people, let's say they would stand up in front of these cubes, just lay them down. And then sometimes you see that they point their hands like a gift to their right hand side, our left hand side. And I think they don't point to that direction just because they like to point there. No, they have a reason. And the nice thing I saw when I filled out these numbers, that the 7 is in the top. I thought of the 7 in heaven. It's just a thought. 2, 7, 2, 7, 2, 7. So it's nice to know that we can visualize a lot. And in an earlier lesson, it was a lesson, an extra lesson to book page 54. You saw the wooden cube. And the wooden cube is built out of 27 smaller cubes. And on each cube there are 12 dots. So 27 times 12. And we only visualize 6 dots. So 27 times 6. So 27 times 12 is 324. It's a very nice number. And half of this is of course the next one. It's 162 dots. Also a very nice number. But on this hexagon there are only 54 dots replaced by a number. But this flat piece of paper with 54 dots is enough to visualize this whole cube. I'm gonna show you how it's done. When you're not able to look inside this figure. You can look inside. So we see an empty space here. This is the far corner. And when you look at this, these three lines, you see these three lines are just the other way around. So this is not an empty space. This is a box. Maybe the box is empty. When you don't visualize anything, the box is empty. So this is an empty space. I'm gonna show you how it looks like when I just put one box inside our empty space. That will be the box, and this would be the rest of our empty space. And then we have to do the floor, where our little box is standing alone in the corner, waiting on 26 other boxes to fill up the space. And again, we just take our numbers and we look for the middle, and we just fill out our numbers. 1, 2, 4, 5, 7, 8. We see the top of the box, 2, 4, 1, 8, 5, 7. And we see it here as well. So maybe a little about Pythagoras in between. We have to realize that one of the teachings from Pythagoras, it was about 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. So in my early days, when I was researching everything, I came with Pythagoras. 1 dot in the middle. But we don't count these dots. These dots are just there to know where to draw your line. And when you look, I looked in books from maybe 1900, 1905, and it was a book. It's not a well-known word by Google. It's I will write it down in Dutch language, and it's stelkunde. Stelkunde. And Google translates it into science. Sacred geometry is a part of mathematics. Stelkunde is a part of mathematics as well. Stelkunde, I didn't read the whole book, but Stelkunde says that the lines are not fixed. You can move the lines in any position. So, for example, when you have one line, the line is not fixed in this direction. You can draw the lines, and then you take all the dots, and then you have a circle. The circle is not a line, The circle is made of all little dots created by this moving line. So when we go back to Pythagoras, maybe we can do more dots. Pythagoras is still inside. So we know that we have 54 triangles. The other ones, we pretend that they're not there, the small ones. So we have 54 triangles, it means we have 54 dots, 54 numbers. But now we're gonna count these dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. 1 in the middle. 18, 12, 6 and 1. 18 and 12 is 30, 36, 37 dots. So there I decided not to count these dots. It's just for our construction. In the end you forget about the whole construction and only the dots are there. And there will be a flow between the dots, or magnetism between them. The 3, 6, 9 you only find in the field between the numbers. I will show it later. So that about Pythagoras, and I'm just gonna make another drawing. So I'm gonna create a little star shape inside here as well. And then again from the star I make 3 boxes. And the rest of our empty space. We couldn't say that they are waiting now for another 24 boxes, because 1 box is underneath. So we see 3 boxes and we visualize the 4th one as well. So 4 boxes are standing in our empty space. This is our empty space, and we could fill out the number like we did here. You see that this 2, 4 is now not inside. Yeah, when we would fill out, but I'm gonna show you something first. So when we look at this 3 boxes, I say 4. Now I show you 4 boxes. I'm gonna show you 4 boxes missing. So that will say we would have an empty space with 23 boxes inside. That would be it. You see, just from a different angle we have a different drawing. It's the point of view. Only 4 boxes in our empty space. Suddenly we have 23 boxes in our empty space. So I'm gonna do it quick for you. We go back here to to the center and we take the 1, 2, 4, 5, 7 and the 8. And then we put the 7 and the 2, we put the 8 and the 4, we put the 5 and the 1, and then the top will be 5, 1, the side will be 7, 2. And you see we have 3 the same boxes. And the nice thing is that this is also a little 369 code, because you see 6, 3, 9. So I thank you for watching, and see you next time.